Children, today we can discuss problems in the miscellaneous exercise. So look at the first question. Without expanding, prove that determinant ABC a square b square c square bc ca ab is equal to determinant 1 1 1 a square b square c square a cube b cube c cube. So we have to prove that using properties of determinant without expanding. So we write LHS ABC a square b square c square BC, CA and AB. Now look here, in the first row nothing is common, second row, third row, like that, columns also. So we can't take anything outside. In the answer the first column is 1 1 1. So we have to take something outside, then only we get like that 1 1 1. So here in the last column, last element BC, if one A is here, and look the next row here CA, if one B is here, then this is ABC, this also ABC, and here if C is here, that is ABC. So ABC will be common. So we need one A in the last place in the first row. So we have to multiply the first row by A. Similarly, second row by B and third row by C. If we multiply at the same time, we have to do division also. Then only this determinant will be equal to the new determinant. So what we do is multiplying R1 by A. We need one A in R1 and multiplying R2 by B and R3 by C. So at the same time you have to divide also. And it is not like matrices. For matrices, if we multiply by A means every element you have to multiply. Here one row or one column you can multiply. So LHS becomes, you have to write 1 by ABC since we are multiplying ABC. Then determinant, the first row becomes A square A cube ABC. Next row is B square B cube ABC, then C square C cube ABC. So ABC is common, we can take out. ABC take out. So ABC by ABC, that cancel. A square B square C square A cube B cube C cube 1 1 1. Here taking out ABC from C3. Now check the answer. In the answer, the 1 1 1 in the first column and A square B square C square in the second column and last column cubes. But here the order is not like that. So we need 1 1 1 in the first column. So we have to interchange. When we interchange two rows or two columns, the value of the sign of the determinant will change. So you have to put one minus sign, then you can write 1 1 1 in the first column. So A square B square C square in the last column and the middle one is A cube B cube C cube. Again we have to interchange. So one more negative sign. So minus 1 square into 1 1 1 A square B square C square. Here what is your operation? C1 and C3 interchanging. Here C2 and C3 interchanging. DQ CQ. Minus 1 square is positive. So it is equal to 1 1 1 A square B square C square and A cube B cube C cube. So that is equal to RHS. So we proved. Okay. Now look at the second question. If A, B, C are real numbers and delta, that is determinant, B plus C, C plus A plus B, C plus A plus B, B plus C and A plus B, B plus C, C plus A equal to 0. If this determinant is equal to 0, show that either A plus B plus C is equal to 0 or A equal to B equal to C. So this value is given as 0. We have to simplify this. Then only we get this answer. So, first we take the determinant. Determinant b plus c, c plus a plus b, c plus a plus b, b plus c, and a plus b, b plus c, c plus a, c equal to 0. This is given. Now, we simplify this determinant. If we expand, we won't get it. It's very difficult to get that answer. So, can we get a common factor? In everywhere, if we check this row, there are 2 A's, 2 B's and 2 C's, like that in every row. So, we can add column wise or row wise, which is easy. In that way you can do. Here I am writing C1 implies C1 plus C2 plus C3. So, C1 is changing. So, add this way. Okay. So, B plus C, the addition is like this, B plus C plus C plus A plus A plus B. That way you have to add C plus A plus B plus B plus C, then A plus B plus B plus C plus C plus A. The next column is C plus A plus B, A plus B, B plus C, B plus C, C plus A. That is equal to 0. Now, look at the first column. The first element is 2 times A, 2A plus 2B plus 2C. Here also 2A plus 2B plus 2C, 2A plus 2B plus 2C. So, we can take that 2 times A plus B plus C outside. Okay. Then first column becomes 1, 1, 1. C plus A plus B, B plus C, A plus B, B plus C, C plus A. So, here taking out 2A, 2B plus 2C, taking out. Okay. Now, what is the next step? 2 times A plus B plus C. Here we have 3 ones. If we get 3 ones, keep 1 1 as itself, and next 2 ones you can convert to 0. So, we can change this one and the next one, that is R2 and R3 we can change. R2 implies, so this you can fix. So, R2 minus R1 and R3 we can write as R3 minus R1. R1 is not changing, only the changes in R2 and R3. So, R1 is 1 C plus A plus B, and R2 becomes 1 minus 1 0. Corresponding elements you have to subtract. A plus B minus C plus A cancel. So, B minus C. B plus C minus A plus B, B cancel. Then we get C minus A. Then the last row again 1 minus 1 0. B plus C minus C plus A becomes B minus A. C plus A minus A plus B becomes C minus B. Now, here look at the first column, only 1 1, remaining element 0. Then you can expand, and also what is given in the question, this delta is equal to 0, that you have to write everywhere. Now, we just expand this. Okay. So, 2 times A plus B plus C into 1 into expanding along C1. Expanding along C1. So, only one element in C1, remaining zeros. So, 1 into, delete the row and column. So, we get this determinant, then cross multiply B minus C into C minus B minus B minus A into C minus A. Then close the bracket. That is equal to 0. That 0 is given in the question. The value is equal to 0. Now, open the bracket. Multiply 2 into A plus B plus C bracket. When we open it, minus B square minus BC minus B square minus C square plus BC minus of BC minus AB minus AC plus A square. square equal to 0. That is 2 times a plus b plus c into, we have minus a square, writing in an order, minus b square, minus b a square, minus b square, minus c square. Then this bc cancelled. Then we have minus of minus plus ab. Then we have one bc here and plus ac is equal to c. So this much we get. But the answer part is not like this. If this delta is equal to 0, you have to prove either a plus b plus c is equal to 0 or a equal to b equal to c. So again we have to simplify that. So what we do is we multiply and divide by 2, and this minus you can take outside. First I take minus outside, okay. Then a square plus b square plus c square minus ab minus bc minus ac. Then we have one 2 here, multiply 2 I am writing here. The next step we can multiply this bracket by this 2. So look, minus a plus b plus c, okay. Then multiplying this bracket by this 2. So 2a square, 2b square, 2c square. Then minus 2ab minus 2bc minus 2ac, okay. Then we rearrange that bracket, a plus b plus c into 2a square means a square plus a square. So 1a square I write here, then 1b square, then this minus 2ab. Is this a perfect square? A square plus b square minus 2ab is a minus b whole square. In that way you have to arrange. So 1b square balance here, 1a square also. Then this b square and c square, 1c square I can take, then minus 2bc. Again this a perfect square. Then 1a square here and 1c square. So look, this bracket we write like this, sum of 3 terms. Then again we can write the bracket as a minus b whole square plus b minus c whole square plus c minus a or a minus c whole square, that's equal to 0. So we simplify that determinant into this form. So here we have 2 factors, a plus b plus c, that's in one bracket and another bracket. So this into this equal to 0 means what we can conclude? We can conclude either this implies either a plus b plus c equal to 0 or the next bracket is 0, a minus b whole square plus b minus c whole square plus c minus a whole square is equal to 0. If for example, if x into y equal to 0 means either x 0 or y 0, that way we write. So here either this 0 or this bracket is 0. This bracket 0 means look at each term, each one is a perfect square. So the perfect square means it's a positive number, okay. So this equal to 0 means each term equal to 0, then only we get a 0. Otherwise this won't be cancelled, everything is a perfect square, everything a positive number. So this 0 implies a minus b 0, b minus c 0, c minus a 0. Then only this the whole term, the sum of these 3 squares is equal to 0. Otherwise it is not possible. So this implies a equal to b, b equal to c and c equal to a. That means all are equal. So what is the conclusion? So either, which implies a plus b plus c 0, either a plus b plus c 0 or a is equal to b is equal to c. That's a question. So once again you go through this. The question, it is given a, b, c are real numbers and determinant is equal to 0. Show that either a plus b plus c equal to 0 or a equal to b equal to c. So determinant equal to 0, then we simplify that determinant. First we add, c1 implies c1 plus c2 plus c3. So we get a common factor that we take outside. So we get 1 1 1. After getting 1 1 1, r1 as itself, r2 and r3 change to the new row and the 0 b minus c, c minus a, 0 b minus a, c minus b. Then we just expanding along c1. Then open the bracket. Then we get like this, and this squares a negative. So we take negative outside. Then a square b square c square minus ab minus bc minus ac. Here either you can multiply and divide by 2 or multiply this bracket by this 2. Okay, 2a square, 2b square, 2c square minus 2ab minus 2bc minus 2ac. Then we rearrange, put like bracket and do a square plus b square minus 2ab. So that becomes a perfect square, like that the second term and third term. So we get product of two factors equal to 0 means either the first factor 0 or the second factor 0. Second factor 0 means each term equal to 0, otherwise it is not possible since it is a perfect square. So from that we get a equal to b equal to c, and the second part is a plus b plus c is equal to 0. So we proved. Okay. Now the same type question. The determinant is same like the previous question. Using properties of determinants, prove that this determinant is equal to 2 into 3abc minus a cube minus b cube minus c cube. So this determinant, like in the previous question, we can simplify. So here I am not writing all the steps. LHS, a plus b, c plus a plus b, b plus c, then a plus b, b plus c, c plus a. Then first step is c1 plus c2 plus c3. So we get 2a, 2b, 2c, that we take outside. So 2 into a plus b plus c. Then we get 1 1 1. Then c plus a plus b, a plus b, or you can copy the final answer from the last question. So it is 2a plus b plus c, then 1 c plus a plus b. Then we subtract r2 minus r1, r3 minus r1. Then we expand. Okay. So 2a plus b plus c into bracket 1 into, delete the row and column. So b minus c into c minus b minus c minus a into b minus a. Then multiply. So 2 times a plus b plus c into bc minus b square minus c square plus bc minus of bc minus ac minus ab plus a square. So that's equal to 2a plus b plus c into minus a square minus b square minus c square, then plus ab plus bc plus ac or c. Okay. This is the last questions, the last step. Then after that, here what is the answer? Answer is given as 2 times 3abc minus a cube minus b cube minus c cube. So here also I am taking this minus outside. So minus 2 into a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Okay. Now do you remember the identity that you have studied in 9th standard, that is a cube plus b cube plus c cube minus 3abc is equal to, there is a result, do you remember that? That's equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. There is an identity like this. So here look, this part a plus b plus c into this bracket, that is same as a cube plus b cube plus c cube minus 3abc. So this is the result that you have to remember. So the LHS is equal to minus 2 into, instead of this much, that is, for that much you can substitute this left hand side. So that's equal to minus 2 into a cube plus b cube plus c cube minus 3abc. Now look at the answer. It is 2 into that minus multiplied to the bracket. So this answer becomes 2 into, if we multiply by negative, 3abc becomes positive, minus a cube minus b cube minus c. So once again you check the answer. The same question as in the previous one. The final, up to the final step you have to write. After this you have to write the identity. The identity is a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So we just substitute for this much, this left hand side. So we get the answer. Okay. Now one more related to the same type, same determinant. Okay, here ABC are positive and unequal. Prove that determinant ABC, BCA, CAB is always positive. So we take the determinant ABC, BCA, CAB. Can we get a common factor? If we add column wise, we get a plus b plus c, a plus b plus c, a plus b plus c, or row wise also you can add. So this is equal to, when we add, when we do this operation, C1 implies C1 plus C2 plus C3, we get a plus b plus c in the first column. Then BCA, CAB. So we can take a plus b plus c outside. A plus b plus c into 1 1 1 BCA, CAB. Now what is the next step? You have to convert 2 ones to 0. So R2 implies R2 minus R1. No change in R1. Using R1 we change R2 and R3. So a plus b plus c into first row 1 BC, 0, C minus B, A minus C, and the last row 0, A minus B, B minus C. Now you have to multiply. Multiply means value of the determinant, cross multiply. A plus b plus c into expanding along C1. So 1 into, delete the row 1 column. So we get C minus B into B minus C minus of A minus C into A minus B. Now open the bracket. A plus B plus C into BC minus C square minus B square plus BC minus of A square minus AB minus AC plus BC. So that's equal to A plus B plus C into A square is negative, B square negative, C square negative, BC, 1 BC we can cancel. Then we have AB plus BC plus C. Okay. Then as in the previous question, we take negative outside, then we write A square plus B square plus C square minus AB minus BC minus CA. Okay. Then we multiply and divide by 2. We have to convert the second bracket in the terms of perfect square. That is why only we do. Because the question, look at the question once again. The question is, we have to prove it is always not positive, children, it is always negative. Okay. From this, look here, we get negative, but we can't say that it is always negative. Negative sign is there, but we don't know what about the value of the second bracket. ABC are given us. ABC are given as positive and unequal. So the first bracket is positive, but the second bracket not sure about whether it is positive or negative. So again we have to simplify. That's why we multiply and divide by 2 as in the previous question. Then multiply the second bracket by this number 2. So minus A plus B plus C by 2. Multiply this bracket with this 2. So that is 2A square, 2B square, 2C square minus 2AB minus 2BC minus 2CA. Now we write the second bracket as perfect squares. Perfect squares. A square plus B square minus 2AB, that put in one bracket. B square plus C square minus 2BC. Then A square plus C square minus 2AC or CA. A minus B whole square, B minus C whole square and C minus A whole square. Now we can conclude. Look, A, B, C are positive and unequal. So A plus B plus C is always positive. Then this bracket, A and B are unequal means this cannot be 0. It is a positive number. This is a positive number, this is a positive number. So this positive quantity into positive quantity, positive into negative is negative. So this quantity is negative, which is always negative. So that is the question. Okay. The question, A, B, C are positive and unequal. Prove that this determinant is always negative. So we proved everything. This is always a negative quantity.